Hello. Let's take a look at our free response question. We're looking at a calculator question. Let's jump right into it. So, we are looking at 2019, question number one. Let's go ahead and read the premise here to start. My mic just fell. Terrible start. All right, and I'm back. So I'm looking at question number one from the 2019 test. Fish enter a lake at a rate modeled by the function e given by e of t equals yada yada. Fish leave the lake at a rate modeled by the function L given by L of t equals yada yada. Both E of t and L of t are measured in fish per hour, and t is measured in hours since midnight. T equals 0. How many fish enter the lake over the 5-hour period from midnight to 5 a.m.? Give your answer to the nearest whole number. So, uh, to address this in general, right? Like, let's look at the problem. And what did they give us? They gave us a rate, right? These are functions that represent rates, all right? So when you integrate a rate from A to B, the result is a total of some kind. All right. When you integrate a rate, of vehicles, of people on an escalator, of fish entering a lake, you're going to get a total amount. So if we want to know how many total fish entered the lake from midnight to 5 a.m., you're simply integrating e of t from 0 to 5. So let's go ahead and plug that into the calculator. So I've got the calculator pulled up here, and I want to go ahead and save e of t. I've got the question pulled out here as well, so I'm going to just type it on the screen, and if you've got it printed out too, then you can reference that. But I'm going to go ahead and type 20 plus 15 times sine of parenthesis. And if you click the button beside the 9, you get this, and you can click on the fraction button, which is kind of nice, and get pi. And where is pi? Pi's right here. Lovely. Pi t over 6. And I'm going to go ahead and, well, let's of course close that parenthesis. And then I'm going to store this. Oops. Going to store. Oh no. Oh, I'm going to store this as e of t. Okay. And then I'm going to go into menu. And I just to do that because I know later in the problem I'm going to use e of t. So I'd rather have it saved sooner than later. And I'm going to integrate, which is option 3, from 0 to 5. Well, let's go ahead. 0 to 5 with respect to t. And I'm going to get the answer. Let's go ahead and get the approximate answer. 153.458. And this is fish we're talking about. Okay? Terrific. We did the first problem. So, as a reminder, right, we integrated a rate to get a total amount of fish. Now, that's the total amount of fish that entered. That doesn't represent the total number of fish in the water, because remember, there are fish that are leaving. This is the total amount of fish that entered. So don't get that mistaken as you're reading through the problem. What is the average number of fish that leave the lake per hour over the 5-hour period from midnight to 5 a.m.? So we're finding an average value of the fish that leave the lake per hour. So what are we finding the average of? We're finding the average of L of t, because that is L of t represents the fish that leave the lake per hour. Now, the per hour is an important touch here, right? We're not finding the average number of fish that left the lake. We're finding the average number of fish that left the lake per hour. So we're finding the average of this rate. So how do you find the average of something? Well, the average value formula is 1 over b minus a from a to b of some function f. That's how you find average value. Because what does this represent? The total. But if you take the total and divide it by the distance between the bounds, you're finding the average, right? Because that is what average is after all. It's add all the numbers together and divide by how many there are. Well, in the case of real life situation with rates, total up how many fish entered or how many fish left the water and divide by how long it took. That's what we're doing here, and that's how we're finding the average value. So we are going to do 1/5 5 minus 0 from 0 to 5 of L of t, the number of fish that left. Okay? So I'm going to go back to the calculator, and hopefully I can backtrack on those words if need be, or you can rewind. But in short, right, an average is total of everything and divide by how many there are. Well, in the context of rates, total up how much there are of this thing and divide by how long it took. That's what we're doing. And thus an average is created. So let's go ahead and go to the calculator and let's save L of t in the calculator just as we did E of t. So I've got 4 plus 2 raised to the power of 0.1 t squared. And we're going to store that as L of t, the fish leaving. Not like that I'm using, must not like that I'm using L. So I'm going to save it as the next letter. After that, let's do M. Oh, apologies. It's because the arrow is in the exponent. Did you notice that? There we go. And then store it as L of t. All right, done. And so what was on my page as a reminder was 1/5 of yada yada. Okay, so I'll go ahead and do the fraction because it makes it look pretty. 1/5 of the integral, so calculus integral from 0 to 5 of L of t with respect. So the average number of fish leaving is 6.059 fish. This is per minute or per hour? Per hour. All right. The next question. Next part. At what time t for 0 through 8 is the greatest number of fish in the lake? So we need to, if we're discussing the fish that are in the lake, what function represents fish that are in the lake? You know what I mean? Like when what function represents that? Well, you have to think about the fish coming and going. All right. So the integral, the integral of of e of t minus L of t from 0 to blah with respect to t is going to represent the total number of fish in the water, right? Because you've got this part of the integral represents the total number of fish that have entered the water. And this part of the integrand, I should say, represents the fish leaving. So if you take the total number of fish who came in and the total number of fish that left, then that's going to give you the total number of fish in the water. And that's what we're trying to find. When is that at a maximum? When is that at a maximum? So this is the function. So when is this at a maximum? Well, the critical points, or the points to consider, are t equals 0, of course, the beginning of the interval, t equals 8, the end of the interval, and when this is equal to 0. Why? Well, this represents the derivative. This is the rate at which fish are coming and going. So we want to know, when is the rate, the derivative, equal to 0? This is the total number of fish that are in the water. So when you derive this with respect to x, the derivative, the rate, is e of t minus L of t. So we want to know, when is that equal to 0? Okay? So if we set that equal to 0, we will find our solution. So let's break out the calculator. So we will solve algebra style. And we want to know, when is e of t minus L of t equal to 0. And we comma x. Where's the comma? Right there. Oh, this is one of those where there's like a million answers, right? Because it's a trig. I plugged this in earlier and I forgot. Okay, so you can do the such. So there's two ways you could go about this. You could graph and shrink your window to the time interval that we care about, or you can do on this screen, you can do such that, and then make sure. Oh, or is it because I did X? I just caught that. There we go. Okay, sorry about that. So if we scroll through here, there's the answer. Apparently, okay. I was like, wait, I don't remember doing this. Anyway, so there's the answer. Why did I ignore all these other ones? Because they aren't within the bounds. It's from a positive, or from 0 to positive 8. So the answer, or the critical point, would be 20356. Okay, so I wrote that down. So we want to consider these 3 points. So the integral from 0 to 0 of e of t minus L of t is 0. We know that much because the bounds are the same. We need to find the other two to figure out which one is the absolute maximum. Is it the end of the interval, or is it the critical point that we just found? Let's find out. So I will go back to the calculator, And I'm just going to plug in that integral. So that's calculus integral from 0. And I mean, again, luckily I have those saved because I can literally just punch that in back to t, and then I need that top bound. So let's do this to 8 first, and I got 80.92, and I'll tack a 0 onto that, so that way it's in the thousands place. And then I'm going to just copy this, Control C, and I'm going to change the number to cooperate. Going to change the number to the other point, which was 6.20356. And I got 135.015. So there's the answer. It is a maximum at t equals that. All right. So if I'm going back to the final answer, let's just remind ourselves, what are we finding? At what time t for 0 to 8 is the greatest number of fish in the lake? Justify your answer. So as far as justification is concerned, presenting the greater with the 3 critical points and plugging them in to the function is your justification. And then you can say the greatest number, how do they phrase it? Sorry, the greatest number of fish in the lake, is at t equals 6.204, because I'll round that up. Okay. And briefly looking at the scoring guidelines for that, because the other two were pretty straightforward, but this earns a point right here. Literally just writing that down earns a point. Solving that, oh no, it says answer, not solving for t. But the answer earns a point. So you saying this earns a point, and then having all of this as justification is your third point. Okay. All right. And then part D, we're gonna be well under 20 some minutes here, which is nice. Is the rate of change in the number of fish in the lake increasing or decreasing? Explain your answer. Is the rate of change increasing? So the rate of change, right, is this. So I'm in highlighter here. So the rate of change of fish in the lake, I'm writing this out more so for your benefit than it is like a final answer, is E of t minus L of t. Okay? This is the rate of change of fish, right? This is the rate of change of fish entering. This is the rate of change of fish leaving. So if you do that, that's the rate of change of fish in the lake. So is this increasing or decreasing at, what was the number? T equals 5. Well, in order to determine that, you need to derive it. So derive each of these and look at, is it greater than 0 or less than 0? Question mark, right? Because to determine whether something is increasing or decreasing, you look to see whether the derivative is positive or negative. Now, what is tough about this question, what I would like to dwell on here, is aren't these already rates? They are. And what do these rates allow us to determine? They allow us to determine if the number of fish in the lake is increasing or decreasing. If the question asks, is the number of fish in the lake increasing or decreasing, you would simply plug the number 5 into these functions because they are the derivative of this mystical function that is the number of fish in the lake. However, that's not what the question asks. It says, is the rate of change increasing or decreasing? So you take the derivative of the rates to see if the rate of change is increasing or decreasing. I hope you follow that logic. So that's what I'm going to do. Let's go to the calculator. And one final time here, good thing I saved E of t and L of t. We're going to do, what's the best way to do this? Honestly, I'm going to do calculus, and I'm going to do derivative at a point, and I'm going to say at 5. Ooh, the variable is t, though. Don't forget that. And hit enter, and we're going to do E of t. Boom. And then I'm going to copy this and do L of t. And then I'm going to copy the answer because I need to do subtraction, right? So that minus that, I hope you're with me, comes out to be negative 10.7228. So what you would want to say is E prime of t minus L prime of t equals negative 10.723, which is less than 0. And therefore, the rate of change of fish in the lake is decreasing. Boom. And to give you the scoring guidelines on this, considers I should say 5 here, not t. 5. Considers E prime of 5 and L prime of 5. So even if you didn't get the right numbers, but you had this written down, you're like, I need to take the derivative. You're going to earn a point. And then the explanation, it says answer with explanation. This is your explanation, less than 0. So you can say that in sentence form, or you can say it with an inequality, but you need to say that it's less than 0. I hope you enjoyed that. In short here, this is really a matter of like, a lot of these questions come down to the language. And I really think B and D is really about language here. So the average number of fish that leave the lake per hour, right? So that's interesting because your answer is a rate. So you're finding an average rate, okay? And then D, because sometimes this question doesn't have the word per hour on it. Just want to stress that, right? Like that doesn't have to be there. So like the language there is particular. And then is the rate of change in the number of fish, is the rate of change increasing or decreasing? Not is the number of fish increasing or decreasing, is the rate of change of the number of fish increasing or decreasing. So pay attention to the language. I hope you learned some things with the calculator as well, or just, it was nice to see that kind of flow through. Anywho, thank you for your time. Appreciate you watching, and I'll catch you in the next one, right? Cheers.